let's finish this animation story with the last one, the La Nina animation. Developing a La Nina, we are going, let's say, again from normal conditions. As I said in the previous podcast, usually even an El Nino terminates and jumps into a La Nina, which is like an exaggerated normal condition, right? During a La Nina, you have colder than normal in the east and warmer than normal in the west. So under normal conditions, you have cold in the east and warm in the west. So you can see here that the development of the La Nina condition is showing upwelling increasing, cold tongue getting stronger, colder, extending further west, the westward currents getting stronger, the West Pacific warm pool being warmer and squished, and rainfall in the west increasing, and the eastern parts, the eastern coasts getting drier than normal. I have lost my cursor, so you have to imagine these things yourself. So that's the La Nina. Okay, so La Nina does have teleconnections as well, as we said, other than increasing floods over parts of Australia, Indonesia, New Guinea, and so on. It also makes for wetter monsoon and East African rainfall. And Nordeste also should respond in the opposite sense to El Nino. During El Nino, it gets a drought. During La Nina, it can get floods or wetter than normal rainy season. Okay, so that's the La Nina part of the story. So big concepts: thermocline, Bjerknes feedback, Walker cell, teleconnections, and transitions from normal to El Nino, and El Nino to normal, or El Nino to La Nina, and normal to La Nina, and back. So these are the concepts that kind of combine all your atmospheric cells, adding the Walker cell. We haven't said what happens to the Hadley cell during an El Nino, but you can imagine as you move the convection in the atmosphere, which is related to the rising air, which means it's related to the poleward branch of the divergence in the upper atmosphere, and sinking, right? So as you spread the warm water during an El Nino, Hadley cell changes. I won't say how because that's going to take more time, but nonetheless, entire system is going to change. Even the ITCZ is going to change. The ITCZ follows the warm water. If you have spread the warm water, then you can imagine the ITCZ is going to be moved further south during an El Nino. During a La Nina, it's going to be pushed further north in the summer months, right? These are the things, again, just connecting the dots, taking all the concepts you have learned and applying wherever appropriate, being able to pull them up whenever needed to add them together. 1 plus 1 plus 1 plus 1.